Alright, so this is the last topic in the exponential function unit, and also for the whole unit for logarithm and exponent as well. Right, so this is on 8.4 exponential equations. So we have talked about how to solve exponential equations with the use of common bases. What do I mean by that? Let me show you an example. For example, if 4 raised to the power of x is 256, find x. Okay, so in this case, we need to convert them into common bases. So this is 4 for the base of the exponent, then 4 raised to the power of what gives you 256. You can try. Okay, 4 to the power of 1, 4 to the power of 2, 4 to the power of 3, 4 to the power of 4, 4 to the power of 4. So 4 to the power of 4 gives you 256. So if you look at this, these two exponential, these two numbers have the same base, so now you can drop them, because the thing is, if they're the same base, that means their exponents must be the same. So that means x is 4, right? No big deal. But then we are now moving on to more advanced stuff. Problem: not all equations can be converted to common bases. Look at the following examples. So if you look at this, doesn't matter how many times you try, or like what different exponents you use, you'll find that you can never write 605 as an exponent with 4. Like 4 raised to the power of what gives you 605. Nope, it doesn't work out. So what you can do, instead of finding a common base and then drop the bases, this time you can actually take the logs on both sides. We sort of did something like this at when we first started the logarithmic function. Now let's go back here. Alright, so it looks like this. We're doing the same thing on both sides, so h is valid. Now let's solve this on the next page. Of course, the easiest way is to express both numbers, the numbers on the left and the number on the right, with the same base and then drop the bases. That would be the easiest. However, if things don't work out, then what you can do is take the log on both sides and then isolate for the unknown and then solve it, basically. Okay, so let's do this. There's no way we can express 605 in terms of the exponent with a base of 4, so therefore we take the logarithm on both sides. So log of 4 raised to the power of x plus 5 equals to log of 605. And then of course, when we solve this, we have to apply the exponent laws. Sorry, I mean the laws of logarithm. So if you don't remember them, I would suggest you to go back to your notes and at least take out a formula sheet so that you know what they are. Product law, function law, power law, change of base law. Alright, so let's do this. So if you look at this, we can actually apply the power law here, put the exponent at the front. So we have x plus 5 times log base of 4. The other side, log 605. There's nothing you can really do with that, so leave that. So after that, what do we have? Of course, isolate the unknown x. So that means get rid of this. To get rid of this, you divide both sides by log 4. Divide this side by log 4, divide this side by log 4. So that means x plus 5 is equal to log of 605 divided by log 4. And then to get rid of 5 so that x can be by itself, afterward minus 5 on each side, so that means x is log of 605 divided by log of 4 and minus 5. And you can plug this into your calculator. I'll do this with you here because this is the first example. Okay, so clear that. Now you can do log 605 divided by log 4. Okay, enter, minus 5. That gives you negative 0.3796 blah blah blah. The question did not mention about the rounding, so let's just keep round it to the nearest hundredth. So our answer is negative 0.38. Okay, so I hope you don't find this too bad. So this one is definitely interesting. Have a look. I hope you can give it a shot first before you continue on with this video here. So anyway, same thing, solve for x, but this time there's no way we can have the common base. So therefore, what do? We take the log on both sides. So of course, when I say take the log on both sides, I mean with base 10, so that we can simply write down log. If you think your life is not miserable enough, you can do the log base 2 or log base 5 or whatever. Okay, so log of this 6 raised to the power of 3x plus 1 equals to log 8 raised to the power of x plus 3. And then of course we can apply the power law by moving the exponent to the front. So left hand side we have 3x plus 1 times log base 6. If you do that, you screw up, put the brackets around, because we have some more math to do by distributing the terms. Okay, like that. And then right hand side, same thing, put the exponent to the front. So x plus 3 will be distributed to log of base 8. And then if you have a look, there's not much we can do. Like, we don't have any other options other than distributing this. And same. So let's do this. So if we distribute that, we have 3x times log 6 and then plus 1 times log 6 equals right hand side, same thing, distribute that. So x times log 8 and then plus 3 times log 8. Okay, after that, of course, we have more simplifying to do. Okay, then put anything with x together, so this and this, put them on the same side, and then anything else to the other side. So this and this should be together. Alright, so move this to the left, so minus x log 8. So that means I have on the left hand side 3x times log 6 minus x times log 8 equals, so move this to the other side, so positive becomes negative, so right hand side I already have 3 log 8, and then move this side to the right, so you flip the sign, so it becomes minus log 6. So now if you look at this, we have a common factor of x, so let's factor out the x. So divide this whole thing by x, you get 3 log 6. So I'm going to take out some brackets because there are million brackets here. Anyway, minus, divide this whole thing by x, so that gives you log 8. And then right hand side, there's nothing you can really do, so leave that as is, except I'm going to take out all the brackets. 3 log 8 minus log 6. Okay, and then after that, to get rid of this, we divide both sides by 3 log 6 minus log 8. So that means x is 3 log 8 minus log 6 divided by 3 log 6. If you want, put a bracket so that it doesn't look different from what we had before on the left hand side, minus log 8. Then you can put the numbers into your calculator, solve for whatever that is. So I'm going to stop here for this one. Okay, so question C is a bit tricky, so that's why I want to go over this with you. And again, I would suggest you to try it first before you continue for this video. Right, so again, whenever possible, we want to have the same common base. Then we can drop the bases and then solve for the unknown, but this time, unfortunately, that's not an option to us. Alright, so in this case, what do? Take a log on both sides. So log 5 times 3 raised to the power of 2x equals to log of 4 raised to the power of x minus 2. Now, I'm sure you guys know some stuff by now that you tend to think that, oh, I can move this to the front, but keep in mind, this 2x only applies to 3. If this 2x applies to the whole thing, then you can move this to the front. Nope. So therefore, we have to split up these two first, and again, by using the product law and then use the power law. So if you're still lost, give me a few seconds. So split them up, these two up. So you have log 5 times 3 raised to the power of 2x. You can write that as log 5 plus log 3 raised to the power of 2x. Because this exponent 2x only applies to 3, it does not apply to 5. That's why you don't see the 2x here. That's why I did not do this right away. I hope now you understand. Okay, then right hand side, well, this applies to this, so therefore we can do the power law. So I'm not going to trick you here. X minus 2 in brackets times log base to the 4. Okay, now I can apply the power law here. Move this to the front. So there's nothing I can move here, so leave that. So log 5 plus 2x times log 3 equals to, there's nothing we can do to the right hand side, x minus 2 times log 4. Okay, just like last question, we group anything with x together. So either move this to this side to the right, or move this to the left, and then the other way, and then same thing for the constant term. So in this case, move this here. before that I was wrong here. We can do something just like last question. We can distribute this, so my apology. So let's erase all this first. Okay, so distribute this, so x times log 4, x times log 4, and then minus 2 times log 4. Alright, so one thing I don't know why I did it this time is by putting down a whole bunch of brackets. You might want to take out the brackets here, take out the brackets here. You might want to use the brackets only when it is a little bit more complicated like this, or more complex I should say. So now we can group the like terms together. Anything with x one side, anything with a constant on the other side. So I'll just move this here. So left hand side I have 2x times log 3. If you move this term to the left, you flip the sign, or you minus x times log 4 on each side, so that gives you minus x log 4. And then right hand side, you already have this, negative 2 log 4, and then move this term to the other side, so minus log 5 on each side, minus log 5. And then as you can see on the left hand side, I have common factors of x, so factor out the x, so divide each term by x, divide this by x, you get 2 log 3. So I'm not going to put the brackets around 2, minus divide this by x, so that gives you log 4. And then right hand side is still that. There's nothing we can really do, I'm sure this time. And then just like last question, to get rid of this, we divide both sides by 2 log 3 minus log 4. So x is negative 2 log 4 minus log 5 divided by 2 log 3 minus log 4. And if you are asked to find the numerical value, then you might want to simply plug all this into your calculator. That's easy. That's just base 10 for all of them. Alright, next question.